and I'm super excited to be here today with Amol Parikh. He is Vice President of Marketing for Doodle Labs, and he is going to fill us in on all of the good things regarding multi-band mesh rider radios.
Thank you everyone for coming. I'm really excited to speak to you today about our multi-band radios. As you can see here, we're talking about multi-band radios as a way of unlocking connectivity and new territories for both air and ground robotics. As she mentioned, if I can get this guy to move with us. My name is Amol Parikh. I'm the VP of Marketing at Doodle Labs. And if you haven't heard about Doodle Labs, but hopefully you have, as she said, we at Doodle Labs design and manufacture industrial-grade wireless networking solutions. We focus on reliable mesh networking over really long distances to provide high throughput mesh capabilities for UAVs, UGVs, AMRs, any kind of ground or air robotics, as well as with our handheld radio, a fully connected Teams solution as well. So before talking about multiband, I have to kind of talk about how choosing a radio was. And that was really choosing a single frequency band based on self-identifying whether you're building a system for government and defense, where you'd use federal bands, or if you're focused on public safety or industrial or commercial use cases, and you'd focus on the ISM bands. Once you've chosen that, you would then choose a specific radio module to then put into your system. We offered single band options as well, and we tried to address that limitation by having form factor compatible radios so that it was still a relatively easy integration process where you would just drop in the other frequency band that you'd need, but it still required a little bit of work. And so I've heard a lot at this show, everyone wants to do less and less integration work. So that's really where multiband came from, because it's multiple frequency bands in one radio. You have that ability to go into the field tactically with multiple frequency bands in that system. You can either operate in them by switching over, or you can know that you have the ability to deploy globally because you have more frequency bands in that robot. So what's the problem? As I was just starting to say, ground and air robots are deployed globally. They are being used in many ways, often dual use, and based on the limitation of if you're in just an ISM band or just one single frequency band, you might say build around the 900 megahertz, which would be really good for a drone system in the US, wouldn't be as good in a drone system in Europe, where they power limit that frequency band. So then that same drone system would probably opt, if they were selling in the US, they want to sell to Europe, they would opt to swap that radio for a 2.4 gigahertz, still sticking to ISM bands. And again, it's not a lot of work when we were using our form factor compatible options, but it again does require a bit of work. And so we see having more frequencies in a single radio as just giving an operator more tools in their toolkit. They have that ability to sell everywhere or in the field to use the one that works the best. So multiple bands in a single radio, as we've done with all of our radios that you see up front, it just gives you a combination. You have a combination of unlicensed frequency bands as well for commercial solutions, and our Helix configuration, which is all of our federal band options for government and defense. We started down this path really with this radio, which is as a form factor, we call the Mini OEM, in the Helix configuration, which is something we developed for the Blue UAS program in sponsorship by DIU. This one radio was really designed around drone systems, so that's what you see is a really low swap footprint, and it houses 6 frequency bands from 1.6 gigahertz up to 2.5 gigahertz in this single radio. That long range, high throughput thing that we focus on with all of our radios really just equates to high performance. Now, we've taken that interest in multiband, or that capability that we feel like it unlocks a lot, and we've taken it and then we've brought it across our form factors and into other frequency configurations as well. All of our radios at Doodle Labs, we have a real intent to provide solutions at scale and on both the commercial and government side of things. So they're really priced to be affordable and something that you can really build out a very large network without breaking the bank. That first one that I was mentioning, this is the 6 frequency bands, M1 through M6 for that DIU GLUES program. The way that we achieve multiband is really leveraging what we've cut our teeth on as RF experts. We use our patented hybrid SDR technology, which allows us to actually convert and frequency switch to achieve these different bands. But it doesn't just rely on the software. We actually have advanced filtration and hardware built into that. So we're really tuning the performance of the radios within each band, and that you're not getting encroachment of other bands into it or other interference that could come in there. This is, as I mentioned, what we really focus on at Doodle Labs. We've been doing it for 20 plus years, really building the best performing long range, high performance radios. We think that multiband unlocks many frequency bands, and being able to use multiband by leveraging base Wi-Fi technology allows us to take advantage of the benefits of Wi-Fi, high bandwidth up to 100 megabits per second, while being able to then leverage the benefits of other frequencies, like again 900 megahertz. That's really good for long ranges, penetration through obstacles, things like that you often get in drone applications. So why use multiband instead of a traditional single band? I mentioned a few of them before, but to list them out is really global deployment. You have the ability to house all of the ones that you would then need to then go into the market wherever you're selling to. Reduce integration effort, because again, you wouldn't need to if you have all the frequencies you need. Optimal interference avoidance. And I think this one's really important. So to dig into it a little bit more, it's something that we've now housed multiple frequency bands in a single radio. We've taken that a step further to actually build the intelligence into the radios to operate intelligently and dynamically. So within a single band, automatic channel selection allows the link to be paying attention to interference coming into the data link and switch over to the least occupied part of a single band. But then when you take advantage of multiband, you're adding in the option to actually switch from one frequency band, say that starts to get a lot of interference, maybe through jamming, maybe it's 2.4 gigahertz and you go over an urban environment, you have a lot of Wi-Fi noise, you have the ability to switch over to a cleaner band altogether. So that's what I was meaning by more tools in the toolkit for the operator, where they just have a lot more options in the field without having to stop the mission, without having to do any extra effort. And then I mentioned the best performing band in the field. So what can a multi-band mesh rider radio be used for? We've really designed our system, our platform, for dual use. It's specifically on the commercial and industrial side. We have customers that are using drone systems for surveying and mapping, inspection, videography, surveillance, all of those, as well as on the government defense side. I mentioned our participation in Blue UAS, our collaboration with DIU, the radio offers that we have. But then again, it's really dual use. As you see at the bottom, there's kind of the frequency configurations that we offer to service each of those verticals. And something that we're working towards, I guess I should mention in a second, is starting with the new way of multi-band mesh rider radio technology. This is the new way of how you choose a radio. First, now instead of having to be limited based on the frequency and kind of the use case that you have in mind, you actually have only one design constraint, and that's what type of system are you building, how big is it, which of these work best for that system. And then based on that, you choose the configuration of frequency bands that you want, and you have that ability to just go to market. So that's why number 3 is deploy. In terms of selecting frequency bands, the ones that you're seeing up here to start with this is the mini OEM, as I was mentioning earlier. We know that a lot of systems are swap, most concerned about swap, size, weight, and power constraints. So we made a nano, which is about half the size of the mini. Then we brought this over to the OEM form factor. While it's a little bit bigger, it provides more flexibility and configurations. And as well as our mesh rider radio, it has a Wi-Fi hotspot. And that same idea is brought over to this one, which is our wearable, with an attachable battery. This is the radio itself, this is the attachable battery that can be vehicle mounted, used as an access point in fixed locations. Even a lot of our customers will throw it up on a pole, like that microphone, or with the battery, it becomes a handheld option. Then you choose the frequency configuration, and this is kind of what I was jumping ahead to, but right now we have our unlicensed options, the 900 and 2.4 together. We have our government options, which cover that helix configuration for DIU, which is the M1 through M6. We've also added to it, going down all the way to L band. We have both L and S in that configuration. And we actually go all the way up to the NATO C band at 4.7 gigahertz. And the dual use is actually what we're working towards, so that you can really just mix and match. You might know which frequency bands you want to operate in, and you can let us know, and you can create kind of a custom configuration that really meets your needs, your particular needs, or your customer's needs. Mentioned this already, and so then to give you some examples of customers that are using this. On the left, you have PDW. These are great partners of ours. Their drone is actually somewhere right over here. Also, you can see it in our booth as well. They're using the helix configuration. They're taking advantage of the multiband as a way to actually tactically be able to avoid interference, again, maybe through jamming. On the commercial side of things, FreeFly is using the 900 megahertz plus 2.4 gigahertz variant. And then on the actually handheld version of this, the AWS team, their disaster response team, is working with us to actually vehicle mount to the radio and then have a team be distributed using the wearable version. And for them, they operate with NGOs and they also go around the world. And so having that ability to have multiple frequency bands when there's no existing network, the infrastructure could be damaged, things like that, gives them just a lot of peace of mind or a lot of that tactical ability to deploy and still have their mobile ad hoc network, their MAN-A with them. They bring their network with them. That's kind of what I wanted to mention to you, and we actually have a lot more that we could share with you if you want to come to our booth at 4416. We have these radios. We have some presentation materials in terms of videos. You also see the booths or the drones that these have been integrated into. But before I leave the stage, are there any questions you guys have about multiband or us at Doodle Labs? So we price them based on the commercial variants or the government variants, the blue variant. So, and again, also based on form factor. But the one that goes into the drones, our starting point is roughly like the 3,000 mark, 2,000 to 3,000 mark. But that's also because our first price break comes in at 10 units. So we really price to scale. The MSRP is really for samples.
And what about the non-blue?
The non-blue is about half of that. Any other questions? Well, if not, thank you so much for coming and sitting through this presentation. I really appreciate it.
Amal, great job. Thank you so much for bringing us a little bit from Doodle Labs.
For sure.
I have to tell you, when you said Legos, I kind of perked up a little bit. To be able to totally customize these batteries, that's fantastic.
That's right. Yeah, we want to be able to work towards like zero integration effort or minimal integration effort. So you have those frequency bands and the radios you want.
That's so fantastic. Those are going to be the best radios out there for sure.
Thanks.
So thanks for doing that. Thanks for the time today.
Yeah.
You guys have to check out his booth in, did you say 1604?
4416.
4416.
Yeah.
I was close.
Yeah.
4416. Go find Amal in his booth.
Yeah.
And thanks, Doodle Labs.
Thank you so much for having me
today.
Yeah, appreciate it.
Have a good one.
Yeah, you too.